Should be straight on. Anybody see it yet?
I don't see it.
Huh?
I don't see it.
Nothing? CSCI. Now you should see this. CSCI 1923
03/11/2020.
12.
Administrative.
Extreme, look for 12, 20, yeah. And then what I got, chapter 4 then, right? Yeah. And what I'm gonna go back to the other. So here, you should see this now.
Okay, yeah, I see it now.
All right, you got it, Miss? Or you don't have to do it. It'll be saved. All right. So, class, we stopped on comparing. We started with comparing strings, but we talked about comparing what numbers and whatnot, right?
Yeah.
When we use the logical operators, what greater than, less than, equal to, greater than, equal to, not equal to. All right. Now, what also I'm gonna show you today is having compound ifs or comparisons. All right, we'll talk about that in a while. All right, so here, comparing strings. All right, so most programming languages allow you to compare strings. Okay, this allows you to create this, decision structures that test values of string. All right, so what it does. Remember what we said about those characters? Each character is stored as a what? Actually as what? No, that number. You remember? Like 8, the letter 8. It's stored as 65, really.
Oh, yeah.
Right.
Yeah.
So, your letters, what's up, Mr. Tucker?
How's it going?
Your letter, right? Your letters have values. So if I try to compare A against B, which one would be the highest?
Well, it depends on what the value of A
Well,
is.
A is 65, or capital A is 65, capital B is 66.
So B would be higher.
Correct. And then
What's the name of that list again?
the ASCII character, ASCII table. And then you got the lowercase letters, which are higher than the uppercase letters. All right? So we remember how we did the comparison with the numbers, right? So to do strings, remember, first of all, we're going to have the actual string header file and declare the string. So let's do that, okay? So let's go to online GDB, all right? So we had online GDB. So now here, let's create a program, pound include, IO. IO stream. Well, I need to do what? Pound include what?
String.
String. And yeah, so. All right. So here we have our shell. So let's declare a string variable, okay? So we can say string word 1, word 2, all right? So now, we can do a cout. All right, in a first word. So we're just gonna enter a word, letter, whatever. All right, in a first word, CN, well, I could do. All right, and that just protects me if I'm gonna enter stuff with spaces, correct? Cout. All right, so now we're gonna get 2 words, correct? But then what we're gonna do, we're gonna try to compare them to see which is greater than which. All right, so what we can do is this. All right, what's up, Mr. Sterling? We could say if word, if I could type, 1 is greater than word 2. Now, the thing is, we're not asking if it's equal to, right? So if they both equal, right, it'll be a false, right?
Right.
It has to be greater than, right? But we could put greater than what? Or what? Equal to. By just simply doing what? This, right? If word 1 is greater than or equal to word 2, right? That's using the operator. All right, if that's the case, we could say see out, all right.
Wait, there's no name for the whole function though. It's just
No, just as the main function.
Oh,
Yeah, it's just one function. All right, well, just a main function. All right, all right. Now you could write all your programs with an extra function. Yeah, you could always do that. But we covered functions. Now we dealing with this with if logic. All right, all right. Then I could say what else? What? See how word 2 is greater than word 1. All right. There you go. All right. So I'll go here. Oh, put 2 up. Word 2 is greater than word 1.
You forgot your streams.
The what?
So you forgot your streams.
My stream. Oh, my stream. You're right. Okay, yeah, you're right about that. All right. So all that's doing is checking to see if word 1 is greater than or equal to word 2. If it is, then I'll put greater than or equal to.
How does it know if it's a string? How does it know that word 1 is greater than word 2?
Okay, what did I just say? When you save those characters, it's actually saving what?
The number.
Right.
So, but when we
If you add them, huh?
oh, I see.
Right. You see?
That makes sense.
All right. So, but it checks each character. The first one is this one greater than, and then you know. All right. So, let's run it. All right. Let's run the program. Hopefully, all the errors are gone. So, it asks us enter the first word. If I type BRCC, all right, for the first one, then I'll type capital BRCC. Which one is greater?
all caps, DRCC.
Which one is greater?
I have to look at that.
All right, look at the first letter. Is B equal to B? Is capital B equal to capital B?
Yeah.
So they both the same. Is capital R equal to a lowercase r?
No.
Which one is greater?
Capital R.
The lowercase.
Yeah, but the lowercase
Hey, why?
b
Why?
is greater than the uppercase b.
I didn't put lowercase b.
Wait, is this going
No,
off of the
right.
address?
You got what I'm saying?
Wait, is that going off the address of the character?
No, it's going off the well, let me pull it up. That ASCII
The
table.
second word would be greater.
So it's basically whatever capital R is in assembly language versus whatever lowercase r is.
No, not in a similar language. Based on the ASCII table. Look here. Look here. Where we go at no, not this one. This one.
Mr. Sylvester, we
Yeah.
having trouble getting in to sign the roll.
What is telling? Oh yeah. No, I changed that the other day.
Oh, okay, I didn't know. Yeah, it just keeps saying class ID not found.
No, first initial, last 4 digit dash.
Yeah, I'm putting that in,
One.
my password just keeps saying it's not the right one, I guess.
Let me ask you this: did you choose CSCI 1923, or it was already up? You may have chose a different class.
I mean, it's just not letting me log in at all, it's a problem, that's all.
No, I'm talking about. So you in the desktop?
Yeah, I'm in the desktop.
Go back to the main screen.
Okay.
Go back to the main
Website.
and not choose the CSCI 1923.
And then go to spiral. from
Right.
there.
Sometimes because sometimes the color of the screens are similar. You
I
know.
got you.
Yeah, they look similar.
Okay.
Try it and see what happens. All right. So let's see here. Let's get to where's our numbers? Oh, let's go back. All right. Look here. Look at the letter A. Letter A. Well, B. B is equal to what? The numeric value.
66.
66. All right. So capital B and capital B was the same, right? But then R, capital R is what? 82. And lowercase r is 114. So 114 is greater than 82. So that automatically makes it what? Greater than other. It's kind of like when you do your remember when you was in like about the 5th, 6th grade and you had to put your words in alphabetical order? And you had to find all the A's, A, B, whatever, A, C, whatever, A, you know.
Right.
So, and like I say, C is greater than B, so you know, we just kind of doing it.
So a whole word, would it be the sum of all the?
No, you're taking each character.
Character.
You start with the characters.
And go from left to right.
Cause watch. Let's check this. Watch. Let's run this. Let's go and let's run this. Oh, not here. Yeah, that was right. That was it here. That's here. All right, let's go back here. So I'm gonna hit enter on this, right? Okay. So now, let's run it again. Come on here.
So lowercase you mean always greater than the.
So I'll type BR, right? Hit enter. Then BR. See? Because the first letter compared, then the second, kind of like I say, you're doing your alphabetical list. But like I say, in your alphabetical list, really the lowest is higher than the others because you're putting in alphabetical order from lowest up, right? So everybody understand how that works.
What is get line?
Get line, y'all don't remember we went over that? Get line says I want to get that entire line until I hit the enter key.
I don't understand.
Blank spaces and everything. But if I use CN and I put Baton Rouge, what's gonna happen? It's gonna take Baton
And then go.
and then Rouge you have to go in, will go into the next input.
Keep everything, including space.
Correct, that's right. The get line says get everything up until, now you even can put a default size in there if you wanted to also.
So you gotta put those
So when you wanna
Okay.
pull.
No, only if you wanted to put blanks.
Multiple things you wanna make sure.
Right.
you get right.
Like here, I just wrote it to where I could put Baton Rouge, and when I hit enter, what it's gonna do? Prompt me for the second. But if I'd have just said CN word 1,
It would have taken.
right, and it just took Baton and put Rouge in the other one, then compare them.
Okay.
So now I could compare Baton Rouge with New Orleans. You understand?
Got it. Yep.
You got me?
Makes sense.
Right. So those spaces are included in that input. Y'all remember we did that assignment?
I don't remember that one, but it makes sense now, so I get it. I
You
totally
see?
get it.
We did that assignment when you had to, you did, y'all didn't do
Look at you giving us stuff.
it. Yeah, that's on me. That's on me. That's on me. All right. But the get line allows you to get up until you hit the enter key. Okay? All
Gotcha.
right, up until you hit the enter key. All right. Okay. So that's comparing words. So even if you had a password that you had to check and whatever, right? You can check a password against another password. Because what? Well, really, if you really understand computer science, more likely, not more likely, a person or you, the user, would have to create your login, right? Just kind of like you did with my class. We had to go through the what? The registration, where you had to put your name, a first name, last name, your major, whatever. And it created a login and it created what? Or you gave what? A password.
Right.
Now, what happens is, in the realm of computer science, right? Now, we're not at that level in programming. When you want to validate a person's user credentials, they would type in their login ID. And there's several ways you can do it. You type in your login ID. You check to see if the login ID exists in a certain file. So it has to do a search for that login ID. If it's found, then you can allow them to type in their password. So once the password is typed in, now you have to match the password with that login, but also the password with the password that they typing in. You understand? Because what? You have to make sure you reference the login and password that's in your file. So you can't read that file and take the login and then read a password of another file. You got to stay and make sure you grab that login password. So once you have that password, you can store it in a variable or whatever. Now you're comparing it to that input variable to see if they are equal. And if they are equal, then you're allowed to enter into the system. Now, there are many different tricks. Yeah, there are many different.
If it's not, then it says something like.
There's many different tricks. Some of them say, oh, well, incorrect. It kicks you out, all the way out. Some of them, oh, well, you have 2 more attempts. After that, your account will be locked. Some of them are just say, okay, log in, not whatever. Many times. Many times. So it just depends on.
Your bank though. Your bank's like,
Right, correct. And your bank will lock it and say, oh, you got to call this number.
Like security questions.
Right, same thing. You have to match that. You go to that database. That question has a answer matched to it, and you have to.
Someone has to put that question in the.
There you go. That's right. But we can look at that later on in the semester. How a file is created. And you can pull the information from a file. And normally, what you can do, you can use structures. But when we first started, we to show you how to use parallel arrays, right? And what that is like I can have a string array of names, like say of 10 names, and then I can have a string array of passwords. So if I go to the fifth element in my array and pull a name, I have to compare the fifth array element in password. You got what I'm saying? Right. So stuff like that.
So you think we're going to do any minor like developing apps by the end of the semester?
No, not developing. No.
What do you think we can do at the end of the semester?
Well, you probably can write, and hopefully, what I would be amazed if you could take the programs we have written, maybe not all of them, because minus some of the one we did with modules, but create all the programs that we do without modules, create a module and a driver file, and call each program into, like I might have
one big program.
Right, I might have a main menu.
As like
Right.
its own module.
Correct. I'd have a main menu, and that main menu might say program assignment 1, or choose which program you want to run. Program assignment 1. You click on that choice, it should go and allow you to execute it, and then return back and give you the main screen. Which one you
know how to make what you call it a drive?
A drive, yeah, but that's like just creating the output screen. That's all.
Oh.
Right.
That'd be kind of cool.
Right. That's what I'm saying. That would be good.
Maybe we could do that for bonus.
Right, maybe. Yeah. And then present it. Don't just do it. Do it and present it. All right. Okay, so that's comparing words, right? And like I said, there's equal compares. If I had one equal, I'll be assigning what that is? Prospero to password rather than comparing it, right? So you got to be careful, all right? Then, like you say, other string comparison. Look what they tell you: uppercase A characters, A through Z, all right, 65 through 90, and then lowercase is from 97.
Oh, that's easy to remember.
Right, you see, and that's standard. You got what I'm saying? That's standard, all right? Now, so look, And what we talked about this, and again, if A is greater than B, which is great, A is less than B, is that true or false? Is A less than B?
Yeah.
No, right, right? Because A is 97
And then B would
and B is 98, right? And look, if you say, well, I'm not sure. If you're not sure, look at the ASCII table. A, 97, B, 98. And it increments as A, B, C, D, E. All right, so on and on. All right? Now, so look, this was the example I was telling you about. When it stores the data in here, you got Mary and you got Mark. What's the only difference in the two names? They both the same size. What's the difference?
The last letter.
The last letter. So as you go through it, the first part, all that's equal until what? Y is greater than K. So Mary will be greater than Mark. Everybody got that? All right? Everybody understand?
So, but when would you ever want to use names
Okay,
value?
if you was trying to put them in a list, in order.
Oh,
Right,
okay.
and like I said, you can start doing the swapping where you can swap this name with that name and put them in the reverse order or the alphabetical order.
Okay.
Right? You can do that. All right. All right. So it's just showing you how it stores them and compares them. All right. So just enter your last name first. Okay. Display. Let's see what this says. Okay. Declare variables to hold two names. Okay. You got first name and last name. I did where it what? With that where it can hold one two names with the space. All right. But what did they do? They put the first name in name 1, the second name in name 2. But look when they output it. All right. When they output it, they said let's see. Display here the name list in alphabetical order. So what? If name 1 is less than name 2, right? I'm gonna output name 1, then name 2, but I only have just 2 names. That's a simple program, right? Otherwise, I'm gonna do what? Reverse it and output name 2, then name 1. Correct? So, because it's gonna be one order or the other, right? So that's all this little program did. It basically did what we did. This one is greater than that one. We didn't print the first one and the last one, and say, oh, this is the alphabetical order or whatever, right? So basically the same thing, all right? Now, we somewhat talked about nested decisions, all right? But now, look here, look at this. If salary is greater than or equal to 30,000, if it is true, then you have to ask the question if years on the job is greater than or equal to 2. If that's true, then you're gonna do one thing or you're gonna do something else, right? But look here, if salary was never greater than 30,000, here, then they won't get the loan. You got what I'm saying? So I think this was something with a loan. They qualified for a loan. So what? So tell me, looking at this, in order for me to qualify for a loan, I had to be what? Number 1, making
Money.
More than 30,000, at least 30,000.
30,000 or more, or at least 30,000, and
Been on your job for at least
2 or more years. You see what I'm saying?
Is that actually true though?
Huh?
Is that actually true though?
No, but what I'm saying, this is a scenario. You got what I'm saying?
Right.
Like when you go to a company and they say, okay, we done hired you. Now we want you to write a program to deal with X, Y, Z, whatever. And you looking at this and say, okay, if a person makes X, Y, Z, then they have so much community service, whatever, then we want to give them a bonus. So you have to be able to put that logic together so you can code it, and right, make it come out right? Okay, so
you can do that in any order. Like you could have put the other one, the job experience on that side.
right, correct. But if you did that, then you'd have to swap true and false. Right. Because there's no real order for true or false. Normally, what I tell students, whichever pattern you follow, start with, follow it throughout.
So false would be else.
Right.
True would be it.
Right. But what I'm saying, look, they have false on the left and true on the right. If you start out that way, continue. Because what you're gonna do, you're gonna get confused. You know, with just looking at your code, you're looking at your flow chart.
True to the right.
Right.
Gotcha.
Correct. And then otherwise, put all true on the right. So like here, you swap this out true on the right. Because you would get, confused, or somebody else would mistakenly see something and thinking it whatever until they look at, oh, that's false. All right? All right. So basically, what happens here? If salary is greater than or equal to 30, curly brace. You got me? Okay? Then what? If job on the job, years on the job greater than or equal to, that was open curly brace. Greater than 2, open curly brace. Everybody got that?
Right.
So let's.
Then you go see how you qualify for the loan.
Right. So let's write that pseudocode up. Well, let's write the actual logic. So what I'm gonna do, I'll leave this up, and I'll go here. So we're not writing the whole program, but we're writing what's on here. All right. So let's look at this. So we see this. Let me minimize it a little bit. You might not be able to see it. So looking at that, what does that say? Okay, and we know we have to create salary, a variable for salary. So we would have to say what? This would be what? If salary, right? Greater than or equal to 30,000, right? Then what? Open curly brace, right? Now, what I would do, being that I have a false here, I would do what? An else. And do open curly brace, right? So I know to come back and do what? My false. Because if I don't put my curly brace or whatever, then I might be confused as to where to put it once I'm typing in all my information for the true condition.
Just like making your body.
Correct.
Do that first.
Right. So now, if salary is greater than or equal to 30, now what? I have another what?
Here's some job.
Another decision, right?
Right.
So what? If years on job greater than or equal to 2, correct? Now, I'm gonna have a what? A true or false or then and else in this one also.
Right.
So watch this. The reason I'll do open, right? And then I'll do here else, and then I'll open. But now I'm gonna show you something. Look how confusing it can be.
Yeah.
This is a if, this is an outer if. And then I have a nested if in that if that has an if and an else.
Would it be better though if you spaced it out? And like as a
But it doesn't execute white spaces though. So you can space it out as much as you want.
right.
Right. So, but I'm just showing you. This is the true.
Right, yeah.
Right. This would be for the true of this.
If and if.
Right? This is the false or the else, which is here, right? But then look here. Once I do this, I kick all the way out of this and continue with the program. So you see how confusing it could be if you don't set it up properly? Now, if I check to see if it's greater than or equal to 30,000 and it's false, where do I go?
All the way down there.
All the way to that else, and then I'm gonna do what? Display this and display this.
And then in the program.
Right. You got what I'm saying?
Yeah.
But if you would mess up those curly braces or whatnot, you can mess up the logic in your program. All right? And believe you
I'd be
me.
so mad if I did a 400-line program.
Right.
With one curly.
And look, you got it where you got. And you have it to where you have close curly brace, close curly brace, close curly brace, close curly brace. Got about 5 or 6 levels of closed curly braces, and you don't know where one stop with the other. You know, it can become very tough. Now, what you can do, you could say right here, / or whatever, because you could always comment after the line.
Yeah,
you know,
a lot.
end of if for years. If I could tell you. You're right. You understand? So you know that that's that end for that one. So if you start adding curly braces, you know, hey, wait a minute, something is going on, right? And here you would say what?
End of the, if for the salary.
End of, I would say end of true condition.
A true.
You understand? Because I still have that what? That false.
Yes, right.
You know, but I'm just saying it's up to you as to how you would make you understand it, right? And that way you know, okay, all this gonna be done. If this is true, I'm either gonna do this and this, and then this is it. So if it falls, it's gonna fall out of here, and this is where I go. You got it? So you can mark up your program however you want with comments, all right? But they can be at the end of a line, or they can be, you can, like you say, you can space it out and put comments. Now, many times you don't want too many comments because you don't want words to overshadow your code. And it just all depends on you, you know, because some people do it for that purpose.
That's what you call your personal style.
Right, that call, what we said, programmer style, right, that's your style, right. So, basically that's what happened. So let's fill in the information. So here, if it's true, it asks that question, then what? We'll be doing see out, you qualifying for the loan, all right? And that will be that, okay? Now, so that's all that will go there, right? And else, the false condition is what? Display this and display that, right? So that will be what? See out.
First one, if you see out, you need two views.
And couldn't you put those two statements into one statement?
And that's basically, this is basically a continuation of that. But I'll do it like they had it. What you saying?
That's what I was saying. You can basically just put that in one.
Right, it's all one word. They just broke it up to not to make a big long
Yeah.
We could just leave that.
box. All right.
You have to declare this variable though, don't you?
Right, that was the same. Remember I said we just gonna do this code, but we could go and create them if you want, you know? And now, look here. This else part, remember? I'm gonna do all of this if it's true. But if it's false, I'm gonna do what? Display this, right?
Right.
So that's what? See how? Now watch, I'm gonna show you something.
So here's a question.
Okay, I'm listening.
Within a nested statement, like after if salary, open curly brace, could you call a module?
You call them out anyway.
Well, I'm saying to do that if years in job, you could make a module saying that, right? Yeah.
Yeah, like rather than me putting C out, I could call a module that I'll put that.
Right.
Right, definitely.
So you wouldn't have to worry about the curly braces.
No, if you're gonna have one line, yeah.
Right, that's what.
Right, yeah, right. But like I say, it could be confusing if you have to add lines and it's like, oh, where I put it, what's going on with it? Right. But I'm saying you can do that. You can do that. Definitely. All right.
You missed the first.
Something not right here. Press double quote. All right, so now, so here we need our variables, right?
Right.
We need what? And we could just
Salary,
right.
years on job.
Water flow. It got in on the flow. Class, remember in C++, it's the letters is case sensitive, right? You see how they have years, then capital O, and then capital J for years on the job? You have to write it out just like that, because if once I declare it to be this, if I try to use it with all lowercase, it's not the same variable.
Right.
It's a different variable.
Yeah,
Because
that's
remember the values, when we talked about the one greater than the other just now with comparison, it's different value, different variable. Alright? So now I can do a C out, C in, let's say C out. Now I'm doing both at the same time. That is on the job. And I'll do a CN. Everybody see what I just did? So you're going to both at the same time. So hopefully I got all the errors on. So let's run it and see what happens. Oh, I need to pull this up. All right, so let's see what happens. So here we got, give me a salary. I should have put a space there. You know, I don't know.
55,000.
Okay. What? Oh, I gotta run it. Okay, 55,000. Let me click here. I don't like this though, but I'll keep it. All right, so 55,000, right?
Right.
How many? What the hell? Oh, the year. How many years? I could put them both at the same time.
40.
40. All right. So should they get the loan?
Yeah.
All right. You qualify for the loan. You see? So let me do this here. All right. And now let's do one. Let's run it again. Give me another scenario.
10,000.
10,000 and 40 years. Right?
Sure.
Right. Should they get the loan?
No.
No, right?
Right.
They gotta be greater than 30.
Right.
Right? You must earn at least 30,000. Right? So let's run it again.
So is that kind of a different logic part there? Because it's two are true. 'Cause both-
No, but you
One's true, but
right, but you gotta understand
right, that's what I'm saying.
this logic is now. You remember I said we're gonna go over compound ifs. This is not a compound. This is nested.
Okay.
So when I asked that first question, it got to be true to do the true part.
Right.
Only for that part.
Right.
But now if it's greater than 30,000 or 2 years, or greater than equal 2 years, then that's different logic altogether. That means somebody could either have $30,000 to get the make $30,000 a year, they could get the loan, or they could just be coming in and make $5,000. But they no, not just be coming in. They can be working for 10 years, or even 3 years, or 2 years, and making $10,000. They still get the loan. Cause of
That's what I'm talking about the logic there. Because like on the solo learn, it'll say if it's true, two statements are true, it's always going to be true.
right, but that's something different we're talking about now.
Oh, okay.
We talking about one statement. Remember?
Right.
The one statement is just if salary is greater than 30,000. Now we can make it like we talking about, but let me enter this last scenario. So I'll put 80,000. Right? Somebody making 80,000 and say they work 1 year. Should not get the loan. You see what I'm saying? So, but if we change this to where, and let me see how we do it. We'll take this out. We'll do this. We'll say, okay, if salary greater than this, and we want the 2 years, and so we want it like, well, I could do it like that. So we want it like this, right? Then we could do it, we could use R. But then I need to take this off, right? If that's true,
The 2 on years on job at the top.
Right.
Where it says if salary is greater than or equal to, and then it doesn't
right.
add.
But see, I need to take all this all this off. I need to take this off. Take this off. If it's true, do that. Else, see, look, we gonna have to say. I need to leave this. Put this here. All right, and then this will have to change because what? And okay, you must have been current for at least 2 years. No, you must make at least whatever and 2 years. You
Right.
see, we'd have to change that statement. You got what I'm saying?
Right.
Because what? This is compound dot.
Ah.
Right, you got what I'm
Okay.
saying?
I see what you're saying now.
Right, so it's gonna change your whole logic
Right.
of your program. Rather than testing for one condition, now I'm testing for two at the same time. And now when they both true is the only time it's gonna fall in the end. You got me?
Right, because before we're talking about salary pretty much.
Right, right.
Qualifying for the
And
loan.
look, there won't even be an else in here. That's what I'm saying. There won't be an else in here. Alright? Right? Because the else will fall outside of here. Right? So you see how your logic will change? But now it says 30,000 and greater than whatever. Right? So if it is, you qualified a loan, but then this has to come out, right?
Right.
And this can go down here into this one, right? You must earn whatever.
Right. You're just
And you
combining-
must-
combining
right.
the statements.
Correct, right. So this comes out, and I got them comments. Them comments will be different too. So you gotta watch that too, right?
Right.
So I'll cut this and I'll put this down here. So now you must earn at least $30,000. You must see, because that's both of the conditions that need to be true. It's not just dealing with only one at this time. So see how you have, when a lot of time when you read the situation, you have to understand exactly what's going on. Alright? Alright? Because your logic can totally change. So it should still run. Let me see if I got too many curly braces. This? No, that's right. I don't need these, no. Or do I? No, I don't need that.
Don't you need to put ends on job is greater than equal to 2 at the first if?
Yeah, I need to put greater than or equal to 2. Yeah. You're right. Because I have to have something to compare.
Or to compare?
Right, right. So it'll do this, you qualify, otherwise, whatever. So when we run it, yeah, that's right. So we put 50,000 and we put say we put 1. You won't qualify, give you all that big list. But if I run it again, and I'll put 31,000 and 2 years, you qualify for it. So you understand? But you can't get that only area you must have 2 years.
Right.
Unless you have another if when you go to that, nested in that, saying if years is less than whatever, give them this message, just give them this message. You know, so you break
And
it.
if you wanted to prompt the user in the second line, you would use ticket line, right? That's why you can do that space.
No, I do CN, because I'm inputting numbers.
Oh, okay.
Right, so I got to use the CN. Right. Right. But I just put them twice, and like you say, all I needed to do was this, CN. But if I did that, I need another C out. Yeah, so I could tell I'll be waiting. No, well, it's there. But normally you would, if you do it this way, you wanna input,
Twice.
yeah, right? So that's comparing, right? All right. So let's look back at notes, all right? Let me make this large. All right. And like I said, this is some of what we saw when we entered the information, so everybody understood the logic of this, all right? And notice they got all them comments. Like I say, comments are good. Like I said, but you don't want I would say, you don't want your program to look like a paper, you know? You can't see none of the code for paragraphs already. But a lot of times it's all just depends.
I saw somebody online, they were saying that you need to put comments around like all your statements or whatever, and I was like,
I wouldn't say that because certain things, when you see something like salary is equal to 0.
yeah, you kinda already know.
Yeah, you know, it's kind of irrelevant to put something on, unless for some reason down in your program, you setting salary to 0 for a specific purpose.
Right.
Then you could say, oh, resetting it to 0 because of whatever.
I guess you could give it like a general description of what the program does before you.
Correct. Yeah, and I'd say that because what happened, what happened?
I was looking at this video on like making a Tetris game in C++, and the guy had each section separated with comments like the game logic or the game timing
Right,
and
right,
stuff like
right.
that. But he didn't use
Right, in the code itself,
He
right,
separated like the
Right,
chunks of
right,
code he was using.
right. Because all you can block your comments. Remember,
Right.
backslash
A lot of
asterisk.
that's just programmer preference, right?
Right, correct. Because I'm telling you, some people write code without any kind of comment.
Yeah, but
I mean, they just write it, and you looking at it, you trying to figure out what's going on. They could come back and look at it. Oh, this, that, one, and that one. Right. But the thing is, you want to comment it because, how would I say it? You can write a program today, and say you're working in an environment, all right, and you write a program today. Now, 2 months later, 5 months later, 1 month later, you've written 5 programs after that, or working on 6, 7 different projects after that, and all of a sudden your boss say, "Look, we need you to go back and modify this because such and such and such is not right in this program." You thought, and you don't have any comments. You wrote it, and now you look at it like, why use this variable here? What is you almost gotta relearn that particular situation because you don't have documentation.
You might go back and debug your own.
Right.
So
Now,
you're helping yourself by doing
right, but never think that you may not go back to your code because in computer science, upgrades, updates, that's our thing. Period. Always trying to make it better.
And you go through so many programs, you can easily forget about how.
What and how you did it, right?
So you
and a little technique you use,
Right.
you know, like, man, I did this, I remember, but I forgot why and how, whatever.
So instead of spending your 3 hours you had that night time down, you could spend 3 hours.
Yeah, all over again.
Right.
That's true. That is true.
Especially
Yep.
when you want a trick you found one time and you really liked it and you don't remember
How you got it? That's right. Yep. And another thing, normally in my 194 class, what I get my students to do, and like say, you got documentation inside the code, which is comment, but I make them do create documentation outside, like a hard copy, or you know, like say, what I tell them to do, a cover page. Cover page would be normally the name of the project, the course name, the semester, the instructor's name, the date is due, the name of the program. All right, cover page. Second page, statement of the problem. What's the statement of the problem? Whatever the assignment is to do. You know, everything that they gave you, the specs of it, variables if they gave you variable names, output if they gave you a sample output, all of that. That's the statement of the problem. All right, because if somebody come behind you to look at your program, why he did this? Oh, this is the statement of the problem. This is what they had to do. So they see what it is you had to do. Then I make them turn in the code itself, hard copy, you know, the source code.
And then documentation.
But that's documentation. That's all in a Word document.
Right, yeah, right, okay.
Then they turn in a screenshot of the output, screenshot of a header file if they got header files, data files if they got data, screenshots of data files, screenshots of the output.
Right.
Then something that they what is that? A data dictionary. What's a data dictionary? A data dictionary is a dictionary in a sense. Normally, my dictionaries only consist of the user-defined variable name, the data type or type, and its purpose. Example, look at this program here. What are the variables or user-defined variables we're using in this program?
Salary, years on job.
Bam, those two, that's it. If we had a module, that's user-defined.
Right.
You have to name, now, what I would tell them, you'd have to, for each module, I want you to list all of the variables you use in each module.
Right.
So sort it, okay, the main, what modules, what functions are being called, and what variables are being defined. You got a module, you call it, name of the module, functions that module calling and the variables are used in that function. No matter what it is. If I do int x equal 1, whatever x is being used for, you're gonna tell me x, whatever x is used for. Any variable created by you, the user, has to be defined. And then, so what happens is, you get in the practice of documenting your work, and so that if ever you gotta go back, oh, why did I use that? Why did I use I and J? Oh, I was to keep track of the subscript for my columns. J was for the subscript of my row. So when I want stuff like that, so you kind of understand what's going on in your program. And like I say, that it helps. They be like, man, this take more time than the program. Sometimes it does. Because you trying to get the program, the midnight hour, you just finishing the program, didn't do any of the documentation. You know? That's how it happened. All right, but that's a good practice if to.
I understand what you're saying. You don't want like your comments to dominate the program either.
I say, yeah, that's my preference there, though. Because when you go to debug it, you don't want to be reading there. You want to be reading the comments. You want to look at the code.
Right.
Yeah, you want to
It's
see.
supposed to be like a general summary.
Right, general description of what's going on with them, and now let me look at my code. And if it's a line that you know you got some or calculation, yeah, just add a comment to the end of it or whatever, and move on. Yeah. Because really, you got to understand, you're not programming just for yourself. Somebody else behind you got to come maybe and update your software or whatever. So you got to be aware of that. So now it's talking about this. We know we did a nested loop, right? The first time we did it, we asked if it was greater than 30,000. Then within that, we asked if it was greater than or equal to 2. All right. So that was nested. Look, basically, if you saw the code, basically what? The same thing. If this, open curly braces. If this, open curly braces, close curly braces. Else, open curly braces, close curly braces. Close curly braces. All right? Open curly braces, else, open curly braces, close curly braces. All right? And that was it. All right? So that's basically the exact same thing. Now, but remember, when we wrote the code, we had to do what after that? We ran it to do what? To test it. Now, I can't just test for anything greater than 30,000. I got to test for something less than 30,000.
Right.
Or less than or equal to. Because what? The assignment says greater than or equal to. And somebody just come put $30,000 and it's like you don't get the loan, you're like something wrong with your logic. So you need to test. And then we had to test for what?
Was it greater than?
The 2 year greater than or equal to 2 years. You understand? So we had to test for those things. Because just because you get output does not mean what? That the program is working correctly. All right, you got to remember.
You gotta test every condition.
Correct.
To make sure that it's.
I'll make sure I don't ever say that again.
I'll just say you gotta test all the conditions.
That's right, because it could be some little thing, like I said, you got everything right, but that one part of it. And it's like somebody will come in, but, oh, it's not working, this not is equal to this. And you're like, oh, I forgot to do that one thing. You know? But you could cost your company some money. You know what I'm saying? So that's always the big thing. You could always cost the company money. All right? All right. So yeah, you always test. I remember we did the grade assignment, right? We did the one with the letter grade, correct? Now, if else, well, we did that. We did the if else, or else if, with the grades. We did the grade. Did we do the grades in this class? No, that was my other class.
We might have done grades,
Oh.
like the test grades.
We did something with a test.
Right, and whether it's A, B, or
Like
C.
90 or something,
Right.
very good, but if it was 100, you got like very good or something like that.
Oh, no, not that one, not that one.
We did that one.
No, all right. Now, the thing is, this section talks about if, then, else, if. So you got an else, but that else got an if with it, all right? So what happens is, I might say, if, just like with the salary. If salary is greater than or equal to 30, do whatever. Then I might say, else if salary is less than 10,000. You got what I'm saying? So I done asked if it's greater than or whatever the 30, now, and it's not, then I ask if it's less than or equal to 20,000. So I done skip what? 21,000 to 29,000, right?
Right.
You say I would be
Right.
like, super don't qualify, cause you only make.
Right, but you see, but you understand, right?
Right.
But that's what this LCF I'm giving an example of would do. Now, so let's take the grade. Let's go into visual, and I think I got a program already written. Let's see something. I don't want this. Here we go. My project. I leave that. All right. Yeah, grades, and that's it is. All right. So let's look at this. Rather than me retype it, look at this. All right. I got what? Char grade. Okay. So now grade would be a letter grade. Then I got int score. All right. But what I could do, I could actually input a score.
Yeah, we did do that.
Right. Huh?
We did do that.
All right. So look what happens. If score is greater than or equal to 90, right? We doing something. But then what? Else, I'm doing an if. I'm not just doing else do something. I'm doing else if.
Right.
You got it? So each time I'm doing an else if. Else if. So else if is greater than or equal to 80, do this. Else equal greater than or equal to 70, do this. Else greater than or equal to 60, do this. Else F. Now, I talked to you about the case switch statement, right? Let's take this program and convert it to a case switch, all right? What happens with the case, rather than keep asking those, having those levels of else if, it'll be like case, what case I want a case on a score. Then I could say, switch on score. Then I can say case, can I do greater than? Can I do? I think I could do that. Let's do it. I know I could ask if it's equal to 1 level. So what I would do here, I would say switch score, all right? Now, if I could type, I'll say switch score. And now, rather than, let's see. I don't think I could do it. Score greater than 90. All right. So if that's the case, no, switch score. Score. All right. Now, here I'd have to open curly brace, because I'd have open and close. So then I'll say case, switch, greater than or equal to 90. All right. Then if that's the case, I can say it's grade is equal to 8. All right. Thank you. That's right. All right. And grade is equal to 8. Now, there's a thing you have to do with the case if you want to exit out. Once I find out that it's an 8, I don't want to check anymore, right? So I would put the command break in it. Okay? So now I'm breaking out of it. Everybody got that? So now I can say case greater than or equal to 80. And then the same thing, grade what? Equals B, right? And then what I want to do once I find out it's a B, I want to break again, right? And then K. So you see how I'm doing that? I'm not doing else if, and I'm going level in the level in the level, all right? Case greater than equal to 70, and then oh no, it's grade, it's spelled wrong. Okay, I think this is what I know. I could ask if it equal grade C, all right, and then break, and case greater than equal to 60, all right, and then grade equals B. All right, now and break. Then what? Once I check to see if it's D, what's the problem? What I know it is now.
Everything else is a F.
All right, so here I do default. So if it's neither one of those, I'll do default, and then I'll do grade is equal to F. All right? So if it's neither one of those previous conditions, it'll default to what? Being a what? F. All right? And then I would break out of it. All right?
We
So-
have to break out of it, at the end like that? Like for the rest of them?
Right, you would.
No,
Right,
check.
but I would break out of it just for the consistency. But you shouldn't have to because that's the last one.
Right, that's what I
Right,
was.
if the only one, yeah.
But
So
it's a good form to just.
right. So now here and then I would print out score and grade, but I need to close my switch. Cause remember, switch I open curly brace, and now I close curly brace. But you see how it's somewhat a little neater than having that else if, whatever else if. You know, this is greater than this else if. All right, and I can have as many statements as I want within my case. All right, I could see out within my case. Okay, I can say see out, found the letter grade, whatever. All right, so let me run this. Hopefully all my errors are gone. Oh no, here we go. See, let's see something. Maybe I have to compare score, but I can't use score. I can't use score because that's the reason. That's the reason why we did it. See. See, you can. I think you don't only can test for a single value. See,
So the switch score thing doesn't, the switch case.
I can't compare this. I have to use this. See, that'll work, but I don't want that. I gotta have the semicolon. See, give me an error. Expect the oh. Let's see something. Still. No. So I'm gonna have to do a single character. Yeah, see, I went to 80. But that's asking if it's equal. So, yeah, the key switch only for the equal. Let me open up the one I did with the valve. Here we go. What like a vowel. All right, so look here. Thought I could do the greater and equal. So here, look. We asking for a letter. All right? Please enter a character. Here we got switch letter. Then we're doing a case on each letter that we want. Now look at this. It's saying you have entered a vowel. So if I put in an A, I'm gonna output you've entered a vowel. You entered a vowel. If I type in an E, you entered a vowel. If I put an I, you entered a vowel. So it's checking for it's only gonna do the equal part. I'm gonna have to research that on the greater than and less than. All right, but then by default, if it's neither one, A, E, I, O, U, you did not enter a vowel. All right, so if you look at it, I got let, char let, input character, which is let, then switch let, which is in the curly which is my argument, and then I got my curly brace, and then for the first one, case. And then the lowercase a, because if I put an uppercase a, what happened?
What?
If I put an uppercase A, what's gonna happen?
It should still, I mean, well,
Different.
It'll be different. Uppercase E, it will be different. So let's run it.
this is only for-
Right. So when I run it, all right, now if I put in uppercase A, you did not enter a vowel, right? So when I run it again and I put a lowercase a and hit enter, you enter a vowel. All right? But rather than me having to check for A, else if E, else if I, else if O, check A, check I, right. And then what? Break, that, well, I put a break. Now watch if I don't put the break. Say I take the break out of, oh, I'm gonna come in. If I take the break out of here, break out of here, and break out of here. Now, say I put in, if I run it, and I put in O, or not O, I, because it just did that. So let me run it. Oh, let me do the A. I'll do the A. Do A. See what happened?
This is gonna
Yeah.
keep.
It went through, but it went through A, and it said what? You entered a vowel, but then it didn't break. It went to the next one, and you entered a vowel. It went to the next I. Well, A, E, I, and it went to O. Right. You got what I'm saying? So, but sometimes you may want it to do that. It depends on your logic. But then, if I'm trying to add, if I'm trying to get a count of each one of my vowels, I don't want to keep a count each time, you understand, like this. I want to add it if it's an A and break on out. And if it loop back up, add it if it's an E, break on out. You got what I'm saying? So that's why, that's the importance of that, you knowing how to use that break. Now, let me show you a command.
So is break only limited to case after using the case?
No,
It can be.
Yeah, you can use it in a function, but you I wouldn't say you wouldn't want to, but you would want your logic to flow, you know what I'm saying, and return back to the function. You know, you don't want to say, okay, I'm gonna break and don't execute this.
Yeah.
Have your logic, if this, do this, and continue, whatever. But sometimes people do it, you know, and like that. Now, check this out. See this command here, C string? This allows me to use some string, what's up, man? Some string functions. One of the string functions is to upper and to lower. To upper takes a lowercase character and make it uppercase. To lower takes a uppercase character. To upper takes a lowercase, make it uppercase. To lower take an uppercase and make it lowercase.
Did I miss anything?
Well, we went over if statements again. So what I would do is, I would do this. Well, not yet. I'll do to upper or to lower, because I'm taking lower. To lower,
Let me know if I missed anything.
all right. To lower, all right, left. So what? Even if I put an uppercase, what'll happen?
Call it like a low.
It's gonna check it as being a lowercase. So now watch.
Let you put your capital.
Right. So watch this. If I put an uppercase, you enter the vowel. Alright, so they all functions, C string.
C string.
Right,
Okay.
right. And then you'll learn that like part of another class or whatever. Alright, but those are like I said, that case, it just checks for equal to something. But I'm gonna check on it a little further. But keep on going through. Look, case statements, we kind of went through it. Look, if it's 3, January 2, whatever. 3, whatever. Default, you got an error. All right, that's the case. We went over the case. What else?
Oh, so that part 2 on the solo learn still open? Because I went home and I just focused on all the codes.
Oh, when it was due? The night? Or
I
what?
don't remember.
I don't think there was a due date because I missed class, but
I
I
just
could
remember
check in
I
and
got
see
all
if
the
anything was
programs.
on
That's
there.
been out.
I don't know if it had like one that you could do a screenshot and upload. I don't think I saw one on there.
Oh, okay, I'm gonna look. Yeah. Now, next class period, we're gonna go by and R. All right. And like I said, we kind of went over the not. But and is inclusive where both have to be true. Or either one. And like I say, what you can do, you could go to the SYL website here. And you can look at that table that you was talking about, Mr.
Yeah, ask you.
No, not the ASCII. It's the Boolean, where is that? Here, the truth table.
Oh,
Right.
Right, okay.
See here? Now, on here, if this will yield true. You see?
Right.
Where P is X greater than Y and Z less than 3.
Right.
So you got comparisons, two different comparisons. If they equal, if they both true, then it will be true. If they one of them true and the other one false, it's false, yield false.
Gotcha.
And that's how you're gonna do your if logic. Just like when we did the 30,000 and the 2.
Right.
They both had to be true because we use and. If either one was false, it would do the false.
Gotcha.
Alright? But then with R, both true is true. Either one true is still true. Alright? But we're gonna go over that on next class because you can have compound, then you can what? Group it, where you can have to solve that one, then based on that one, then solve going from inside out.
Gotcha.
Alright? So we'll work on that next class
Have a
period.
good night.
Alright, y'all.